What's going on, everyone? It's Sora A, and welcome back for a deep dive into the world of mobile processors. These tiny chips power everything we do on our phones, from scrolling through feeds to capturing epic photos. But have you ever wondered what makes these pocket powerhouses tick? In this video, we're breaking down everything you need to know about mobile processors. We'll be exploring the different architectures, core components, and even how these chips are manufactured. Whether you're a tech enthusiast or just curious about what's inside your smartphone, this video is for you. So, grab your favorite device, get comfortable, and let's get started. Alright, let's kick things off by talking about architecture. When we talk about processor architecture, we're essentially talking about the fundamental design and instruction set that a processor uses. Think of it like the blueprint for how the processor understands and executes commands. In the mobile world, we primarily see two main architectures, ARM and x86. ARM, which stands for Advanced RISC Machine, is by far the most dominant architecture in mobile devices. It's known for its energy efficiency, making it ideal for smartphones and tablets where battery life is crucial. Then you've got x86, which is the architecture primarily found in laptops and desktops. Intel, the company synonymous with x86, has tried to break into the mobile market, but ARM's efficiency has kept it on top. Understanding the basic architecture of mobile processors gives you a foundation for understanding how these chips are designed to handle the demands of your smartphone or tablet. Let's dive into the core components of a mobile processor. At the heart is the CPU, the brains of the operation. It executes instructions, runs applications, and manages data. Modern CPUs are multi-core, handling multiple tasks simultaneously. Next, the GPU handles graphics, rendering images and videos. The NPU is for AI tasks like machine learning and image recognition. Finally, the DSP handles audio, video, and sensor data processing. So, we've talked about the individual components, but how are they organized within a mobile processor? Well, that's where core configurations come in. Chipset manufacturers use different core configurations to strike a balance between performance and power efficiency. One of the most common configurations is the big dot, little architecture, primarily used in ARM-based processors. In this setup, you have a cluster of high-performance cores, the big cores designed for demanding tasks, and a cluster of energy-efficient cores, the little cores, for handling lighter workloads. The idea is to dynamically switch between these clusters based on the task at hand. If you're just browsing the web or checking email, the device will primarily use the little cores to conserve battery life, fire up a graphically intensive game, and the big cores kick in to provide the necessary horsepower. Another approach is hybrid core designs. These configurations feature a mix of different core types optimized for specific tasks. Ultimately, the ideal core configuration depends on the intended use case of the device. Now, let's talk about the manufacturing process behind these incredibly complex chips. The term process node gets thrown around a lot, but what does it actually mean? In simple terms, the process node refers to the size of the transistors used to build a processor. Transistors are like tiny electronic switches that control the flow of electricity. The smaller the transistors, the more you can fit on a chip, leading to increased performance and power efficiency. We often hear about processors being built on a 7 nanometer, 5 nanometer, or even 4 nanometer process. These numbers, measured in nanometers, represent the size of the transistors. A smaller process node generally translates to a more powerful and efficient chip. A smaller node means less distance for electrons to travel, which reduces resistance and power consumption. This constant drive towards smaller nodes is a continuous race in the semiconductor industry. However, shrinking these transistors down to such incredibly small sizes presents significant engineering challenges. Alright, so we've covered a lot of technical details, but how do you actually measure the performance of a mobile processor? Well, there are a few key metrics to keep in mind. One of the most commonly cited metrics is clock speed, measured in gigahertz. This refers to the frequency at which the processor's cores can execute instructions. Generally speaking, a higher clock speed means faster processing. However, clock speed alone doesn't tell the whole story. A processor's architecture, core configuration, and other factors also play a significant role in overall performance. That's where benchmarks come in. Benchmarks are standardized tests designed to measure the performance of different processors across various workloads. They provide a more comprehensive view of a processor's capabilities beyond just clock speed. Popular benchmark platforms like Geekbench, Antutu, and 3DMark run a series of tests that simulate real-world usage scenarios like web browsing, gaming, and video editing. The results are then compiled into an overall score, allowing for easier comparison between different processors. While benchmarks can be helpful, it's always a good idea to consider a processor's overall capabilities and features in the context of your specific needs and usage patterns. With all this processing power packed into such a small space, heat generation is a major consideration in mobile processor design. Excessive heat can lead to performance degradation, reduced battery life, and even damage to the device. That's where thermal management comes in. Mobile processors employ various techniques to manage heat and maintain optimal operating temperatures. One common method is thermal throttling. This is a mechanism where the processor automatically reduces its clock speed or performance when it detects excessive heat. While thermal throttling helps prevent damage, it can also result in noticeable slowdowns, especially during demanding tasks like gaming or video editing. To mitigate this, manufacturers are constantly innovating on cooling solutions. Modern smartphones often incorporate advanced cooling systems to dissipate heat more effectively. These can include heat pipes, vapor chambers, and even graphite pads that draw heat away from the processor and spread it across a larger surface area. Effective thermal management is crucial for ensuring consistent performance, maximizing battery life, and preventing long-term damage to your device. Now that we understand mobile processors, let's look at the major players. Qualcomm's Snapdragon processors power many devices, known for performance and features. Apple's A-series chips are optimized for iOS, leading in performance and efficiency. Samsung's Exynos chips excel in graphics and camera features. MediaTek offers a balance of performance and affordability. Each company pushes the boundaries of mobile computing. In today's hyper-connected world, seamless connectivity is no longer a luxury, it's a necessity. And mobile processors play a crucial role in delivering the fast, reliable connections we rely on. One of the most significant advancements in recent years is the integration of 5G modems into mobile processors. 5G, the latest generation of cellular technology, promises significantly faster download and upload speeds, lower latency, and increased capacity. With integrated 5G modems, smartphones can take full advantage of these next-generation networks, enabling lightning-fast downloads, seamless streaming, and lag-free online gaming. Modern mobile processors also include support for the latest Wi-Fi standards, such as Wi-Fi 6 and Wi-Fi 6E. As we move towards a more interconnected world, the role of the mobile processor in handling these connections will only become more critical. As technology evolves at an unrelenting pace, the future of mobile processors is brimming with exciting possibilities. Let's explore some key trends shaping the next generation of mobile computing. AI integration into mobile processors is a significant trend. Dedicated AI processing units, or NPUs, are becoming standard in flagship devices. These NPUs enable sophisticated AI applications like on-device language translation and advanced health monitoring. Another trend is the pursuit of smaller process nodes. Smaller nodes bring improvements in performance and power efficiency. We're also seeing the rise of new processor architectures like RISC-V. RISC-V offers a customizable alternative to proprietary architectures like ARM. The future of mobile processors is full of exciting possibilities. So, there you have it. We've journeyed through the intricate world of mobile processors, from their core components and architectures to the latest trends shaping their future. These tiny chips have become the unsung heroes of our digital lives, powering the devices we rely on every day. As you continue to scroll, game, and connect, take a moment to appreciate the incredible engineering and innovation packed into that small but mighty processor inside your device. It's a testament to human ingenuity and the relentless pursuit of technological advancement. If you enjoyed this deep dive into the world of mobile processors, don't forget to give this video a thumbs up, subscribe to the channel for more tech insights, and hit the notification bell so you don't miss out on future explorations. Until next time, keep exploring the ever-evolving world of technology.